all that stuff. So it is a short introduction that will allow some interaction between us, okay?
Certainly, yeah, so I can introduce myself and what my involvement in these sort of projects has been over the last couple of years. And my name is Lewis Dartnell, and I'm a research professor at the University of Westminster in London. And my involvement in this area of studying these sort of projects was within my side career in science writing. So I'm a research scientist, but also write science books on the side. And my previous book was called The Knowledge: How to Rebuild Our World from Scratch, which was taking as a premise, as the start of a thought experiment, a hypothetical scenario of there's been some kind of global catastrophe, some kind of apocalypse event, a doomsday event, the sort of thing we see in the cinema, but taking that as an assumption that it's happened, that you've lost the supportive network and infrastructure that we all just take for granted nowadays in our modern, industrialized, cozy lifestyles in the West and in the developed world. And through the pages of the book, therefore, explored the question, how much do any of us actually know about the basics of where things come from, the raw materials, the processes that they are put through to create the products that rely upon, the things you pick up in a supermarket without a second's thought on a Saturday afternoon. And how much of that could you do yourself if you ever had to? How could you go back to basics and the first principles to make and do things from scratch for yourself? And how does that network of understanding and scientific knowledge give you new technologies and inventions, which then themselves enable you to do more things and connect with each other? So this is where the sort of things I talk about overlaps very nicely with Marcine's work on the global village constructor set, where I've been taking a more theoretical, paper-based approach for the mass market for this book. And Marcine's been putting his money where his mouth is and actually making these sort of self-sustaining infrastructure networks. I don't know if any of the audience, and I don't know where it is because I've not seen the link, but I delivered a 45-minute talk going into a lot of depth on those sort of broad brushstroke concepts, which I don't think is perhaps worth repeating now. But perhaps if that goes up in the chat box or something, Martina, I don't know how that can be made available. But that is my background and my interest in this area of fabrication, back to basics, fulfillment and the satisfaction you get from making and doing things yourself, and therefore how that links into appropriate technology, intermediate technologies, helping developing nations, and that area of real world applications of the sort of knowledge base that we're talking about.
Excellent, thank you. Hi everyone, I'm Anna Waldman-Brown. I know some of you. Marcine, it's a pleasure to see you. I've been following Global Village Construction Set since back in the day, and Vinay, great to see you outside of a hacker camp. I will be moderating this afternoon or evening. First of all, are there any comments for Lewis?
Lewis, how likely do you think your scenario situation is at this point?
Irrelevantly likely for the point of the thought experiment I was trying to run through. I just wanted to have a scenario set up on page 1 where everything that we take for granted can no longer be taken for granted, so that people sat in their comfy seats at home, their sofas at home, or sat in a cafe reading a book, have the rug pulled from beneath their feet and start thinking about themselves sort of questions that, you know, us community of people on this call right now spend a lot of their time thinking about, or indeed many people around the world are in fact already experiencing as their day-to-day life. You know, it is that realization that us in the developed world have an exceedingly privileged and comfortable life, but it's not something we should take for granted because many people don't live that lifestyle. And indeed, it's not beyond the boundaries of possibility that lifestyle could be taken away from us in, as I said, some kind of Hollywood-style sudden apocalyptic event, which we watch on TV screens, or indeed what seems to be more likely to be a long, slow, grinding decline under the current climate, or climate, to excuse the pun, of global warming and environmental degradation and all the issues we're very, very aware of. I don't pin, page one of the book, The Knowledge, doesn't pin itself to any particular catastrophic event in particular, because that's unnecessary, as far as I saw it.
I have a question. Can you guys hear me?
Yep.
All right. So Lewis, are you doing, with the book written, is any of your other research related to developing any of the things that you talk about as products, kind of like we do? Because I always talk about, okay, well, how do you get this out into the real life?
Sure.
Yeah.
So my actual research field is in astrobiology and the possibility of life on other planets.
Different.
Which is, it's a little bit different, but it's similar in the sense that it's very interdisciplinary. And I've in fact come from a biological background, and I've learned a lot of planetary science, geology, physics, sort of robotics along the way in my research career, and have had conversations with people who work at places like ESA and NASA of applying the overlap between those two different interests. If you are trying to establish a self-sustaining colony on Mars, which is something that people like Elon Musk get very, very excited about. And indeed, I think they have a pretty solid argument in the long term. It's something that we would want to do as a species to not keep all our eggs in one basket and protect our long-term future. How would one go about that? How does one condense down to a seed, a kernel, all of the infrastructure and capability and machinery that you need to support a community of humans, put it on the point end of a rocket, and then unpack your suitcase when you arrive on Mars? And of course, the challenges for doing that on Mars are a great deal more difficult for doing it in an undeveloped region of the Earth, where you can't even take basic raw materials on Mars for granted, such as air you can breathe or water you can scoop up in a cup and drink. So there are real world applications in that sense, although I also can see that is still pretty blue skies and out there compared to much of the work that other people on this call do, such as Vinay, who I wanted to bring into the conversation because I'm a huge fan, and I know he does a lot of work in this sort of area.
Yes, Vinay.
There we go. Hey, how's it going? Good to see you. Yeah, I mean, I don't know, where do we go? So Vinay Gupta, got interested in open hardware when I accidentally designed this thing called the Hexayart, a very simple open source building. We've done a bunch of innovation on that platform over the past 20 years. And the reason the project is still alive is because when I started it, I assumed it was going to take 30 years to get to global deployable capacity. So planning over the horizon that way caused me to run the project as a hobby rather than assuming I was going to be able to raise funding for it. That framing kind of gives me a particular kind of grim patience. The world is burning on pretty much the trajectory that I imagined 30 years ago. The interest in doing something comprehensive about moving hundreds of millions of people is slowly beginning to build. And unfortunately, we're on the trajectory where my work might be relevant. 6 years ago, I basically ran out of money doing disaster relief stuff and said, sod it, I'm going to go and get a real job. Joined the Ethereum Foundation and spent 6 years since then in the blockchain space. One of the few people in the space to not get spectacularly rich because I took legal advice a little too early. So I am a working engineer. I run a company. We're VC funded. And what we're doing is very high resolution legal structures for tracking physical goods. Initially things like fine art or wine, and then eventually Bruce Sterling's spine vision reified and made flesh. So yeah, that. I mean, it'll come in useful eventually. When you start putting hundreds of millions of hectares in the field, you want to be able to track individual units and figure out who paid for them. So the work will eventually come back together. a technology base for managing physical assets in an extremely austere environment, that's a useful thing. We're going to get execution specifications in there, executable specifications, so you can verify whether you've got the necessary raw materials and the necessary tools to manufacture an object. We're working towards things which are useful again, but those things are still probably years out.
Yeah, great points, everyone. Feel free to type questions in the chat or raise your hand. If you hit reactions, then you can click raise hand, and I can call on you. I'm curious, while we're waiting for a quiet audience, for Lewis, I think one of the big differences between restarting civilization on Earth versus, packing up a kit that makes almost anything and going to Mars is that even if knowledge is so scattered across our Byzantine supply chains network, we still will be starting from a lot of various broken pieces. So I'm curious what you think about the difference between sort of starting from scratch and starting from, let's say, like a broken apart infrastructure network, whether that's, in an emerging market or in downtown New York.
Sure. So, there's a series of related questions that have the same core at their heart, but differ in the exact parameters or sort of axioms of where you're starting from. And as I said, for the sake of what was a mass market popular science book, I went with what I thought would be quite zeitgeisty. And I don't mention the Z word, I don't mention the zombie word anywhere in the book, but it's kind of applied because that's the conceptual touchstone that I think most people can absorb and understand. So I was dealing with that project from a cold start, as it were. But to address your question, if we were to be trying to do this for real on Mars, it of course isn't a cold start. You're not trying to scrabble and scavenge for what you need in a devastated wasteland of some kind of post-collapse environment. You can do it with the infrastructure that we already have set up in the world today. But as I said, the similarity is still the same. It's trying to think about what is the sort of the minimum viable product or the minimum network that you need, which is self-sustaining and self-sufficient, that can be packed into a small space and then unfurl like a lotus flower when you arrive. And again, there's popular touchstones for this sort of thing in Martian and Andy Weir's excellent book, although it needed a bit of editing before it first came out. And then the film with Matt Damon, it's dealing with a similar idea. There are these, I think with a lot of, an important point perhaps to make with a lot of these projects is if you're trying to engage large numbers of people to think along these lines, it's to begin from a foundation of what they perhaps already appreciate and understand, which is why I go for these cultural references. But yes, for starting a colony on Mars, you already have the established infrastructure here to enable you to do that and pack it up. But on the other hand, there are much more extreme environmental conditions that you need to be able to protect the humans from and challenges to solve.
Right. I loved the hacking of the abandoned Mars rovers in The Martian. There was a little bit of infrastructure there. Yeah, great points. I see Leopold has joined us. Do you have a question? You're on video.
Excuse me. Maybe it's very interesting if we could have a round of insights related to that important question that you put on the table. So let's try that starting by Joshua, then Marcin and Binai, if you agree.
Mm-hmm.
Yeah, go ahead.
Okay.
Hello, everybody. My name is Joshua Pierce. I'm a professor at Western University in the other London in Canada, and I do work on solar photovoltaics and open source hardware. And so I came to open hardware maybe a decade ago now at this point. I'd been a little bit involved in open source software, but it really became apparent to me when I was working in my own lab just to do solar cell research that to build on the work of others, there was really something behind kind of the open source movement applied to hardware. And for me, really, it was the RepRap project that kind of opened my eyes. We'd been working on a solar powered laptop for the developing world. And I'd finally, like finally as a big professor, I got access to a rapid prototyper. I was so excited because it was the first time, I used to keep a little invention notebook next to my bed at night and try to invent something every night before I went to sleep. And I could finally make this stuff. But the thing they didn't tell you at the time was, even though you had access to these tools, they cost a small fortune. And so that little plastic cover that was going to snap onto the back of the laptop to make it solar powered cost almost as much as the laptop and more than the solar cells and all the electronics. And so this was never going to work. And so I was looking around for how I could do rapid prototyping cheap so that you could even think about doing it in the developing world. And actually a project from Britain, the RepRap project, had just been started. And I knew immediately that this was going to be huge and that I was going to be part of it. And I think any engineer that hasn't seen the RepRap, it's a 3D printer that prints its own components. If that doesn't make you salivate, you're probably not an actual engineer. And so my lab group kind of jumped into it full score. And we started off just by making things as they broke. And so the light bulb really went off into my head that this was ready for showtime when I had a filter wheel changer break in my lab. And so a filter wheel changer just rotates and basically changes the color or the intensity of light that you're shining on a solar cell. And it's a very specialized component. So to get it fixed, it was $2,500. And that was pretty pricey for something so simple. But the bigger hit was that it was going to be weeks and weeks right at the beginning of the summer that I had to wait to get it ordered because hardly anybody in the world uses these things. And so I hired a high school student to design one in OpenSCAD, print it on the RepRap, and he did it in a couple of weeks. He did it faster than I could have purchased it. And the one that he designed was parametric. And so it not only solved my problem, it solved everybody's problem for the rest of the time that has anything to do with filter wheel changing. And so it only cost $50. And so it cost far, far less. It was a superior technical device. And it was digitally made so that you could, now that the files are shared and anybody that wants to make for themselves, you need to know the basics of Arduino, which is an open source electronics platform, a little bit about 3D printing, and you can make it on yourself. And so that's when my lab kind of went all the way over. Like, we don't buy equipment anymore. We make it ourselves. We buy it from open source vendors so that we have total control of it. And that same principle that we're using to do kind of the high-end science goes all the way down to the poorest of the poor. You just need access to some of the basic tools, like solar photovoltaic panels to convert sunlight into electricity, which is available pretty much everywhere. And now at a low enough cost that it's starting to become accessible to at least the poor in the West, but soon the poor everywhere. And digital replication technologies. So RepRap was the first, but now we've got lots and lots of tools, whether it's PCB mills or laser cutters that allow, or basically anything Marcin does, that allow you to make the things for civilization. And I think getting to kind of Lewis's dream of, having the information that you need to recreate civilization, whether it's, right here on Earth in a kind of underdeveloped area, or after a catastrophe, or on Mars, that's within our power now. And that is coming on fast. When I started in this, I was actually very worried that my first kind of professor job where I'd switched over to open source stuff, I was very concerned it was going to destroy my career. And so I kind of, I'm very conservative. So I did two things. I did the open source stuff and I kept the solar stuff going, just like made sure I was always employable. But as it turned out, my most recent job is to do open source stuff. I got a raise. I got a really nice position. I'm chaired to do open hardware. And if there's anyone on here that has any interest in getting a PhD in open hardware, I'm hiring. So like, this is real now. This is not make believe. You can run your whole life this way if you want to, because it's a superior way to develop technology. I can say, I've had very, very smart students in my lab. We've made some amazing things, but the truth is the reason that we're productive and the reason that we write so many papers and gets the technology rolling so fast is help from outside. We get help from all over the place. People I've never met that comment on the wiki stuff that we do on Wikipedia, to people that write, code that we then incorporated in our own devices. I mean, it truly is superior. Software's known it for a long time, and hardware, I think, is catching up.
Fantastic.
We haven't heard from Marcin.
Fantastic. It's all converging. So let's, am I,
yep,
my
we can hear you.
is on. Let's talk about, so the other thing that's happening right now also is the rock bottom price of PV panels. Let's talk about that, because that brings about some new opportunities. When we started this, I started this about a decade ago. In fact, in 2004 was when open source ecology was first formulated. In my last year of the PhD, where unlike Joshua, I tried to make myself unemployable because this world was not for me. So I moved out to the middle of nowhere. But at that time, you can talk about like, what was the cost of solar cells at that time? Maybe like, I don't know, $4, whatever it was. But right now it's like 10x. I mean, just think about what that makes possible. So for a long time, I thought about, okay, hydrogen too, hydrogen. Solar is there, just like RepRap, 3D printing is there. Nobody knows about it. I mean, the technology diffuses only so fast throughout the rest of civilization. There's first adopters, like for us, Joshua, others, 3D printing is natural. For many people, it's like, what? That exists even. So technology doesn't spread as fast as you'd like. But with the solar revolution, wow, very few people know that it's extremely feasible right now. You can go off grid right now. Like this house here, the cost of the system that we're doing is actually 1/10 of what I pay on a grid. It's 1.2 cents per kilowatt hour right now. Okay, and take that further, going back to the dream. So when I studied energy, I studied fusion, and then I got back into solar energy because I thought fusion was too complicated. So I talk a lot about, I wanted to get into appropriate technology. But right now, so at that time, hydrogen was like, okay, cool. But electricity to do electrolysis, if you get it from water, so that's green hydrogen. Very simple. There's plenty of water, absolute abundance. You can have dirty hydrogen from fossil fuels too. That's not what we're talking about. But right now with solar panels, if the cost is what it, like if you can do a system that's about 1 cent per kilowatt hour, you won't read a lot about that in the mainstream media. Let's say the price may be a little higher than that number. Maybe some industrial systems, large scale systems can attain like a 1 cent. I mean, Joshua, what is the official cost of PV on an industrial scale? Like how much can you produce a kilowatt hour for?
So in India, you can get down to a few pennies now. In the US, it's a little bit more than that, maybe 6 or 7, and
yeah,
coming down. But you're right. The point is, it's now the lowest cost form of electricity, and the smaller systems for residential are higher than that. Like the system on my house is maybe 15 cents per kilowatt hour, but I have to pay 20 cents, so I'm still making money. The trick, though, is to do it yourself, just like everything else that we're talking about. If you start to manufacture, say, the racking for yourself, that's the most expensive component at this point. And like the BIPV work that you do, Marcin, it's like BIPV costs much more unless you do it yourself, and then it costs less. Right.
Right, and that's exactly what we're doing. So we're combining a bit of open source design, do it yourself, building integrated, but we're at, for real, 1.2 cents. So if that is real, and we can do that, and we can scale that through open source by teaching others and disseminating that, for example, makes hydrogen feasible. If you look at, okay, here's a cost of X cents per kilowatt hour for electricity. Well, we actually are getting down to this. I went through the numbers. We're getting to like 80 cents or so gasoline gallon equivalent if we can replicate the kinds of costs that we're getting right now. So that's pretty amazing. And just to say where we're at right now. So right now we're actually getting into building housing, low-cost housing, the City of a Home project. You might have seen that, all open source design. But our next hit, I'd just like to introduce that here as one place. Not this year or next year, but perhaps the year after we do a little bit of the housework as a replicable revenue model, we're getting into the hydrogen. But simply, you can even burn it in internal combustion engines. No fuel cells required. Keep that low tech appropriate, and cause a revolution like that. But only if you, yeah, it's hard to, like, if I say this to somebody, they kind of might roll their eyes. It is I do believe it's a real possibility here on Earth and anywhere else to get that kind of low cost. And I think that is where the open source distributed development, distributed energy systems come into place. And of course, the current system is not going to really promote solving that question because there's a lot of industrial inertia. That's where I think the open source collaborative development really has a part to continue developing the electrolyzers, storage systems, and all those things, like the myths around hydrogen that it might explode and things like that. Those things like about storage and safety, that's all been resolved. That's been resolved for decades. Right now, the price was the only thing that's killing it. But yeah, that's what I'm excited these days, and that would definitely be a thing where, okay, now you can have truly distributed autonomous energy. Even though PV is feasible right now, a lot of people are uncomfortable with the idea that, oh, well, you can't store it for the night. Well, one side is efficiency. You can if you have a very smart system doing that. But on the other hand, if you want to run life like it is today, and you don't even see a difference, then some storage would come in. But that's just a thought that comes in.
But I think you're right, and I think the storage is slightly behind the PV technology, but for small systems, and that's something that I think, you know, when we look at you developing a solar system in the West, we're thinking about, you know, a house with a dishwasher and that kind of thing. And I lived in Finland for a year, and nobody has dishwashers there, so like it's all very specific to your location. And if you're just looking to solar power, you know, your lights or your computer or your cell phone, that's very doable. And building those systems is approachable by everybody. Lonnie Grafman, who was the founder of Appropedia, and I are just putting together a free book on the subject, kind of collecting all the things that Appropedians have developed over the last, you know, decade or more, and some of the stuff my lab has put together. And these are systems that everybody can build, and certainly kind of within the Fab Lab community, this is baby stuff. Like, you guys could do this. Everybody on this call, I'm sure, could build a solar system in an afternoon with batteries. Hydrogen will be slightly longer, maybe 2 days.
Well,
Yeah.
we want to invite our guests to raise his hands and ask something to our panelists.
How do I get a PhD in open source hardware? Is that real?
That's totally real. So I've actually have several students that have gone through where their thesis topic is something like development of open source blankety blank. So it's really just a matter of finding a project and the advisor and getting funding to match up. So right now at Western, I've got two big lines. One is open source solar photovoltaic development. And so we're going to be doing a lot of racking, a lot of systems design over the next little bit. And then the other one is DRAM, which stands for distributed recycling and additive manufacturing. But the idea is you take plastic trash in your neighborhood or from your own house, grind it up, turn it into feedstock that you then can put into a 3D printer. And that 3D printing, whatever you're 3D printing then, whether it's products for sale or things that you need for your own home, the technologies to do all that, there's definitely chains to do that. And many people have proven that it's physically possible. What the challenge is and what we're working on now is to make it easy enough that you don't need a PhD to make it happen. And so probably the area that I'm most excited about doing now is coupling computer vision and AI to 3D printing systems so that they fix themselves during the print. Because anyone that's used one of these knows that it's not perfect just yet.
So less spaghetti.
You're right, absolutely.
Lewis, did you have a question?
I had a quick question. What sort of sources of funding are you able to get for the PhD students for open source projects? Is that, I would have thought, quite hard to come by?
I thought it was, but it's just not. So for example, my largest source of funding now is a multi-million-dollar DARPA project, and you think DARPA would be like top secret. That's not how they are at all. They want results, period, and they don't care how you do it. And when we put in the application, the open source hardware was written all over the place. And that particular project is a plastic recycling project too, but it's further out there. So their goal is to make waste plastic in the field, like you're in the back of a Humvee, you throw it into a black box, and out comes protein powder. And that sounds insane, but we actually have proven every step along the way. It's me, 2 chemical engineers, and 2 biologists. And the biologists have things that they pulled out of the lake that can eat plastic, and we maybe will be able to eat them. We haven't proven that it's not toxic protein yet, but it's protein. And then all the tools to take the plastic and break it down, we're making open source hardware. So we're using open source bioreactors, hydrocyclones to get the water out, like the whole thing. The drying unit is an open source vacuum dryer that we've already published. So like in the end, anyone that wants to create a company off of this or to do it for a completely non-military type application is more than welcome. They just wanted a solution in the field so that they could get something useful out of basically MRE packets that they don't want to load or they don't want to carry them around, so they turn them into something useful. And so that funding is funding multiple PhDs to try to make this happen. And that's pretty mainstream. Like it's not even radical. So there's DOE funding, NSF funding, at least in the US. In Canada, I'll be mostly looking at NSERC and then foundations and that kind of thing.
Yes, Leopold.
Where can I find this documentation? Because I think that's one of the big problems in open source hardware, that there are a lot of interesting projects, but it's very hard to find them because we are missing a good repository. But maybe I should make a short introduction of myself. I'm born in Vienna. I'm sitting in Vienna, but I bought some land on the countryside, and I want to move there in the next years. And currently, we are doing some things on the countryside which are not easy possible in the city because we have much more space. But in general, I thought a lot about it, and I'm sure that I want to make a shift from the classical Fab Lab because I find it boring to print some funny plastic stuff with 3D printer. I'm more interested in printing with clay, and I'm interested in biomaterials, and I'm interested in the Wood Wide Web and in nature and sustainability. So I think we need something which they call in Germany open eco labs, with a shift on the focus what the Fab Labs are doing. And I would like to mention we have some interesting flagship projects in Austria. Like one project, it's the Vivi House. It's an architecture project, and we have a project with a centennial washing machine. And I think it's very important to mention that almost everybody associates electronics with open source hardware, and open source hardware is much more than electronics.
Thank you, Leopold.
Yeah, great points. We have a question here from John, who it's a pleasure to have you here, who has one of the almost certainly one of the world's largest distributed manufacturing networks, eNable, of prosthetic hands. So he's wanting details about why it might be toxic and how presumably that chemical engineering works.
Yeah. Yeah, so I just submitted the paper on it, and I'd be happy to send anybody a preview. So we're using HPLC mass spec work to try to, but the problem is you have a bunch of different microbes, like a whole consortia, hundreds probably. We have no idea what they are and which ones were responsible for which plastic. We also don't know what plastic's going in and what contaminants there are. So you have just a big mess, and then you're having a bigger mess, eat it, and then you're getting something out on the other side. So you have no idea what that is. And so the only way to do this, like the old-fashioned way, would be you would do a bunch of lab rat studies with each chemical that you found in it. And each one of those lab rat studies costs $1 million. And to give you a feel for this, I did it on leaf extract from red maple leaves, which is the most common maple leaf, or most common leaf in tree in North America. And there were something like 47,000 chemicals in it. So you can see how this gets absurdly, ridiculously expensive very fast. And so what we attempted to do is to use a completely open source software toolchain to identify all of the chemicals in this goo and then compare it to the European Open Toxic Database. And from that, then we get a number of things. And then those we need to run back through the system to identify exactly what they are. And then we'll back trace and see if we can figure out if that's something we can either eliminate from the food source coming in, or maybe we need to, cut out a couple of microbes. So this is really, DARPA is all about next. So we're just starting. But the basics of the toxic analysis I've already published about the leaf, and you can use that same protocol to do anything, basically, any kind of non-targeted toxic screening. But it's scary. I don't want to kill anyone.
Can I ask a dumb question here? Is there any concern that these microbes will figure out how to infect everybody's electronics and eat the plastic that runs civilization? Or do they need specialized environments to survive in?
That's actually a great question, because I had something similar. So
this is the ring world problem, right? The ring world, the books, they wind up with a mold that eats their superconductors and their civilization implodes. This is Lewis's collapse scenario.
Mm-hmm. It's the Andromeda strain as well, isn't it? It's the Michael Crichton Andromeda strain, where it started eating rubber.
Does it eat? Oh, it eats rubber. Okay.
We haven't tested rubber yet. We're just focusing mostly on the most common, like polypropylene, PET, HDPE, those types of plastics. And the microbes that we're working with right now are all natural. We do have a professional biohacker on the team, and he's trying to get it so that we can produce preferentially different types of things, like more fat or higher protein percentages. And those microbes have, they're already chosen because they eat, say, a breakdown product of one of the plastics. And then he's trying to amp up their ability to produce what we're aiming at. Mm-hmm. Those ones, I was like, well, what happens if they start out competing everything and destroy all the natural bacteria? But the bio people on the project assure me that they're the weak ones, and they will be destroyed in the natural environment long before.
Levenger's law, right? Levenger's law, wild type always wins.
Right. Yeah, but this is to me, it's all sci-fi anyway, right? I'm much more of a hard scientist. The gooey stuff makes me uncomfortable, I will be honest.
John? You have a question?
Can I comment on this? So let's talk about the collaboration part, open source and collaborative. So any of these problems here could be solved readily, like overnight or in a week or a year, if enough energy, focused energy came about to do it. So what are your observations maybe in the house, since we've got some open hardware heavy hitters here? What are your observations on the limits to collaboration? Because in our work over the last decade, we simply say it's the collaborative literacy part, the fact that people do not understand what collaboration truly is, based on the proprietary world we live in. But how do we have some ideas of how to start breaking down those barriers? It's encouraging that you're at the university. Maybe we can start pumping students through collaborations, like recently actually with the GI Bill. If that's a possibility, I'd like to definitely talk to you, follow up on that, because we're getting connected to that. Imagine we feed a bunch of GI Bill funded open hardware hackers into the program. But let's talk about collaboration. Any comments on that? What are the limits and how do we break them down?
So it's unexpectedly hard, So we've got, Hexair project probably has at this point 10,000 people that are capable of building a Hexair. Maybe it's 5,000. They're building a few tens of thousands, 10,000 units a year. 6 commercial enterprises building them at this point. But there's really, really minimal collaboration. There's not much innovation. People have figured out the design works, and then at that point, they're very reluctant to touch it. So there's it was a huge surprise to me that you could wind up with scale, but without innovation. Most of the innovation is still driven by me kind of getting people to do stuff for me, like, hey, I think this would be cool if it did this. could you take a crack at that? Oh yeah, sure, I could do that. And you know, like I basically have to nudge people to get most of that kind of stuff moving. And that's really surprising. Shouldn't be surprising in that you see the same thing with Wikipedia and you see the same thing with Linux. Enormous numbers of users, very few contributors. So in a sense, that's a sign of success. But I think that we have a sort of notion of like, you know, if you've got 50 users, you sort of think you might have half a dozen contributors. And it's actually more like if you've got 50,000 users, you might have 200 contributors.
I think you're right. And Marcin, I think you hit on this is the biggest challenge. And possibly it goes back to what Leopold was saying, is that we don't have a good open hardware centralized database. Like I use Appropedia all the time. I find it really good, but and I know Vinny's used it a little bit as well. But
all the Hexer stuff lives there. There is no other Hexer resource. Okay.
And that has the potential to be it, but I know, like, from, you know, working with hundreds of students over the years, if they're forced to use a wiki in a class, they will do it for the grade. But then the number that stay on and continue to contribute is depressingly small. And being in it, it's very hard to see why everyone doesn't do this type of work. It's fun, it's exciting, you're trying to help people, you're helping yourself. Like, why would you work on it? But the fact is, it's still immensely challenging to have people have the willingness to open something up. And, you know, kind of within the Fab Lab community and the open hardware community as a whole, you've got these, you know, they're willing to take apart their toaster and fix it. But the vast majority of people aren't comfortable doing that. And that's where I think education really needs to get there. I mean, where everybody feels comfortable doing everything. And right now it's really pretty sad. And even within the university, even within engineering, it's very common to have like a mechanical engineer not know how basic electricity works, or an electrical engineer like not understand how like gears work. So we're all used to being pigeon-tailed and becoming these super experts, but there's something to be said for having a little bit of knowledge in everything so that you can play. Well, John has a good point. Sorry.
Well, it's not I want to point out that I think there's a really important insight in what you two have just commented on. And I think we should recognize that for the foreseeable future, there's going to be a relatively small number of oddballs like present company who thrive on this sort of innovative, creative, let's try something and make it up. And we're going to be a minority. And actually, we will waste our time if we try to convert the masses into the oddball state. So there are two opportunities in that. One is, we don't do such a good job of collaborating with each other either, right? We don't have to blame the other guys that don't use Wikipedia. We're all working on our own silos, and that's something that we ought to address. And secondly, we've just recognized that there's a world of people out there who could pick up and scale up our solutions if we made them available. And we should figure out how to repackage what we have done that appeals to us in such a way that it is packaged not to make us feel good, but to make them feel, hey, I can do this, what the hell?
Mm-hmm. Okay, so what is any solutions, John, since you've thought about the question?
Well, yeah, to the second one, I do think that writing documentation intended not for the person who's writing it, but for the people who need to read it, is a classic problem. And it's a very hard one to get around, but it's not rocket science. But, you know, those of us who are so busy trying to do cool stuff often write the record in order to satisfy ourselves, not to satisfy the people who could adopt it. That, I think, is a relatively well understood problem. The knottier problem of how this sort of creative open source brain trust can collaborate in a more focused way in order to sort of put the point of the spear where it needs to be, which I think has to do with the survival of civilization and the planet, I don't yet have a good answer to. But I think we really ought to be focusing on it because there's a lot at stake.
Yeah, absolutely. It reminds me, I was watching some machine learning scientists talking the other day about how one of the big problems with making AI explainable is that the engineers who are trying to make this AI tell them what it's actually doing are the least equipped to know like what the average person wants to know from this AI. And so if you're talking about like a robot that's making quality control decisions in a factory, right? It's not, that robot shouldn't be talking to the engineers who are designing the robot. That robot should be talking to the lay people who are trying to use it. And so I think that that problem gets extremely magnified when like you have no incentives whatsoever for documentation. And then these engineers are trying to figure out like how to communicate. I'm curious, and I see Isak has joined us, he's been working on this as well. What good examples have you all seen in terms of incentivizing collaboration or really sparking that like 1 to 2% of innovators to engage with the network?
What makes you think it's as high as 1 or 2%?
Wikipedia numbers are about 1 to 2% are active contributors. So that's not even like the people who do most of the pages. I would guess it's more like 0.1% or the people who do everything.
I was going to say, because I mean, that fixing a typo here and there might be 1 or 2%.
Yeah.
But writing a page from scratch, can anybody find stats?
I don't know.
The other thing is Wikipedia has definitely changed. So like maybe 10 or 20 years ago, back when it was started, it was, I would say, a nurturing community, sort of like Apropedia is now, where people are there to help you and to build it. Nowadays, you know, the Wikipedia has actually shrunk, and it's shrunk because the few kind of super users are just slashing and burning everything. There was a battle over RepRap a couple years ago where they killed the page, and it's like, what are you guys doing? Like this is exactly what Wikipedia was built to put up, and it took months for the fighting to finally stop. And so I think part of that is, you know, everybody wants to be the king of their little tiny kingdom. We have to find a way to have collaboration in a way that keeps everything there, so that we're always able to build upon each other. And you know, in software, they've got the Git system that works fairly well, but normal people are not going to be able to use that unless it gets substantially easier.
I mean, I basically run my company on Git, not for software, but for documentation for physical assets. And teaching, you know, museum curator types to use Git in the workplace. Oh my God.
So I think we still need to crack. I think that is something we could put some substantial brain power in, as to how to do proper, especially for open hardware, you know, based building upon each other's work. Like, you know, John, you'd asked about like creating filament from waste plastic, and that is still pretty hard. Like, it's hard to get a recycle bot that functions well. And to date, my paper with the most figures in it is the recycle bot paper. It had more than 100 freaking figures on how to build one, and it's still not good enough, frankly. Like, we still get emails all the time. So it's like, it needs to be done better. It needs to be made easier. And that goes for basically everything. So there's still tons of engineering that needs to go into making kind of a truly distributed, fabricatable civilization, because that's just one stinking device. There's at least 50 that we need to get civilization going.
If only somebody had a map of those systems. I kind of remember hearing something about a project that did that. So what I'm about to drop 2 open hardware projects that we're basically doing the commercial infrastructure for. So the first is a plywood violin project run by a fellow by the name of Robert Brewer Young, who is a violin maker, a luthier. So he's been trying to figure out how to get it such that you can do CNC cutting of off-cut wood from people that are selling to the professional violin makers. And you take the offcuts, you cut them in CNC machines, and then a high school wood shop has the rest of the tooling that you would need to put these things together. Because it turns out at the end of the day that violins are more or less the kind of things that you can make with pretty much a knife and infinite patience, which is pretty much the tooling that they had back in the day, right? You start with a log and you remove everything which isn't the violin, and then you glue the remaining pieces together. So there's that, and there's also a 1,000-year clock project. And the 1,000-year clock is about 4 feet across. It's a spectacular looking object made by an artist in New Zealand. And what we're going to do is we're going to package all of these things up using the same structure that we're currently using for doing provenance of gold bars. So we've got a legal structure where you can take multiple sources of truth about an object, each one of which is contributing different information. So this guy says the gold bar is really in the vault. You know, this guy over here says that the gold bar has the following number. This guy over here says that the gold bar will be released under the following legal conditions. And each one of these things is bound to a legal warranty. So if that fact turns out not to be true in a way that damages the owner of the object, they get paid. And we're gradually integrating this into the DeFi ecosystem. So, you know, 6 months from now, we'll have all singing, all dancing insurance products that back this stuff up rather than individuals having liability. And what we're planning on doing is basically loading up all the plans from which an object was manufactured. So we do a certification from the author of the plans. This is the set of plans that I put in. Then we have an authorization from somebody who has manufactured it that says I manufactured it to that spec. And then we have 1, 2, 3 independent verifiers that compare the object at the end of the process to the specification and vouch for it. And in the context of the distributed manufacturing, the kind of idea is that you would manufacture a violin, then you would get the violin inspected by multiple independent third parties, then a foundation would buy the violin, which is how you would get paid, and then they would lease the violin to young musicians that wanted to play the violin. So you might buy the violin for $100, and then you might lease it for $3 a year or something like that. And that allows you to impose maintenance conditions as part of the lease, so the violins will be taken care of, and so that we don't accidentally, you know, wind up with them just wandering off and this kind of stuff. So that as an approach, you know, we could take any substantial chunk of open hardware and we could do that with it. And that begins to create the legal frameworks, because preventing people from manufacturing things is basically not the point, right? We don't want to prevent people from manufacturing things. That is not the name of the game. But doing the quality assurance to verify that something is up to the standard of the original planning, that is a service, and people could charge money for doing that service as a way of making money from their innovations. Might be, for example, a business model for OSE. The designs are free, but if you want us to stamp this thing as you actually manufactured it to spec, we inspect and you pay us to inspect, and then we put a digital signature on it. So although I've been kind of inactive on the Hexier front because, you know, like it just wasn't clear what the next move was, we were very stuck on that. Other than the little homeless encampment we did in LA, which is another story. But the what I have been doing is I've been working towards building the legal infrastructure so that we could build a blockchain-based market for open hardware using these new business models and authentication techniques as a way of validating the hardware is up to specification, but also getting the original designers of the plan paid. So, you know, watch this space this year.
Do you see an application to, for example, say we're building a block in Kansas City, I don't know, any applications that you can see, say we are making open source housing. How do we apply it today? Maybe some value provided to the city that needs some validation on, oh, this got certain qualities.
So, I mean, if you, how hard do you want to lean on this? Because there are things we can do. So
let's do it.
Suppose you take a set of plans and then you sell the housing off the set of plans, right? We guarantee that in 18 months, there will be 12 houses for sale to the following specification on the following patch of land. You buy this commercial right to live in that house from us, but you open it up for a secondary market. So somebody buys that right before you've broken the ground, and they're taking a big risk, so they get a pretty low price. Over the course of the project, it becomes more and more certain that that house will get built, and they can then sell those tokens on to the people that actually expect to buy those houses and live in it. And what you're doing here is you're using speculators as a way of financing the property development. Now, that as an approach, right? You then have to provide some kind of meaningful guarantee that the house has received will be the same as the house has promised. And to bridge that gap, you have a set of people that essentially come in as guarantors for different part of the work. I'm doing the roof, I guarantee the roof will be up to spec. I'm doing the windows, I guarantee the windows will be up to spec. Each one of the crafts people involved in the production of the house puts out an independent an independent warranty on the work that they're doing. And the crux of this is they get paid not just for doing the work, but when the house changes hands, they get a residual fee if the work that they've done is still in functional condition. So it incentivizes people not only to do the job right the first time, but to make sure the stuff is durable, because they're getting a fee every time the house changes hands from the new owner, not to buy the piping or the roof, but to buy the guarantee that the piping and the roof will still be there in 25 years. We're basically trying to build the structural economics of an open source permafactor.
Vinny, have you written this up anywhere?
We have a product. We're selling it right now.
Okay. Send us links. Send us links.
Yeah. I mean, this this is what the company does. We went out. The gold bars are basically, you know, what we're attempting. Gold bars and fine art are what we're going to do to pay the bills. But the open source stuff is kind of still very much part of the picture. Let me see if I can find an asset passport.
Vinay, if we are training the people to build, because part of the issue is that there may be some very high-priced trades that do things in a complicated way. We're simplifying things.
Mm-hmm.
How would you see that working in this model? Then simply the guarantors are the people we train?
Well, you've got to guarantee that the stuff works, right? And yes, all the way through this, somebody has to figure out who's picking up the slack. Right? You know, if something is going to get screwed up, somebody's going to have to pay. And the question is, who is going to have to pay? So is it the person that did the work? Is it the buyer of the house? Is it some third-party guarantor? Is it society? I just pasted it in the chat. There is an NFT for a physical object.
You know, feel free to share your screen. It's
yeah, I can
enable.
Box, yeah.
Hang on, I'm just going to paste another link into the chat just so we got everything in one place. So if people want to follow along, they can. No, that did not work. Give me a second. Let me actually paste the link here.
For something like a house, would this complicate? Because I know economists love to talk about the net present value decreases over time. Mm-hmm. And so you could actually incentivize that the value of some object to stick around. So does this intersect with like the right to repair laws in terms of making things more repairable or?
Absolutely. So you can see the figure. So this is a thing on a website called OpenSea. OpenSea is basically eBay for NFTs. So 99% of what's for sale on OpenSea is digital art, which is being sold for cryptocurrency. We then loaded into that physical objects using a bunch of esoteric legal hackery. And the physical objects include things like gold bars, fine art. You know, I think the most expensive thing we've sold so far is about $8,000, but we've only been operational for about a month. If anybody knows friends who run like sneaker companies and want to sell like high-end sneakers as NFTs, come and give us a shout. So you document the object, you stick the object in a vault, you sell the NFT of the object, right? That's the most primitive and most controlled form of this technology. Once you get the objects out of the vault and they're protected by legal structures rather than by physical walls, you're basically kind of moving towards Bruce Sterling's spine vision. So here's the, so you've seen the OpenSea side of it. This is a thing called an asset passport, and this is the legal identity of the object, which is being sold using this OpenSea NFT. So the NFT is basically like a transferable deed that people can buy and sell that gives them the right to take the object out of the vault. And then what this is the legal information that defines what the object is that they're buying sight unseen. Does that make sense so far? Because this is a pretty crazy story.
It is a crazy story. Can you emphasize again, objects protected by law, not walls? What was that?
So right now, all the things that we're buying and selling, they're only for sale while they're sitting inside of a vault. So the physical object is put into a vault, then the right to take the physical object out of the vault is being bought and sold as an NFT, right? That's phase one. In phase two, we take the object out, we put the object into a trust, and then the trust leases you the object, right? Then you do what you like with the object, and when the time comes to get rid of the object again, you find a new person, you instruct the trust that they're the new custodian of the object, and then you do a financial transaction and hand them the goods. They then certify that the goods are in the correct condition. If they are, they accept them and they pay you. If they reject the goods at that point, then at that point you're stuck with them. You have to fix them before you can sell them. So this also has implications for things like fleet property.
Why don't you just start with the trust? Why the vault and the NFT to begin with?
You phone somebody up and ask for a vault, and they give you a vault, and it costs you $300 a month. You phone somebody up and ask for a trust, and you wind up talking to lawyers for 6 months. Trust structures are super slippery, and there's enough value in vaults to keep us busy for a while. So gold, whiskey, art storage in places like the Geneva Freeport, you know, there's enough stuff to be doing in that we hope to build a profitable business doing that, and then we can extend out into the more complex cases as we go. So let me show you the kind of payload on this. So we have a set of reference images of the object, and if we were dealing with open hardware, these things would be schematics of the object as it ought to exist, and maybe pictures of what it would look like if you built it properly, or they would be pictures of the actual object that had been manufactured. And you could put, you know, DXFs or whatever else you had in here. Then you get to this little doohickey, which is the legal contract. So the legal contract is basically 14 pages of legalese that says, if the description that I gave you was wrong, I will pay you the following amount of money. And every time the asset changes hands and it's bought by one person, the person who buys it pays a residual fee to each one of the people that offered these guarantees, so that they are covered by the same guarantees as the original purchaser. So this provides this residual income stream to the people who provided the original information about the object. And this is potentially how we get people paid for designing open hardware.
But doesn't the open hardware designers then take on like a continuous liability? Like that would scare the tar out of me.
Well, the continuous liability is, and this is a delicate thing, right? So if the liability you're taking on is that I designed this, these are the plans, I've built it and it worked, right? If you build it correctly, you've got the same results I did, and here's the lab performance data. How much do you want to get paid for making the guarantee that your plan works? Right? The plan is free to anybody that wants it for free. If you want to pay for a little bit of cover in case it's a fiasco, you pay a little money. If you want to pay a lot of money in case it's a fiasco, you pay a lot of money.
So really, it's about monetizing your ability to subsume risk. So like if we use like an eco home as an example, I'm fairly confident Marcin's plans are solid, but I would be very concerned, say someone messes up the plumbing and then, you know, you don't notice it for a little bit, person goes on vacation, house is flooded, millions of dollars of, I don't know, art is destroyed, and then you're on the hook for it.
So you're on the hook for the amount of price that you want to absorb. So if I say, right, I guarantee that if you follow these instructions correctly, you're going to get a working rep wrap, right? You do the design, Bob does the construction, Harry buys the printer, right? So you sell a license that says, if you follow the instructions correctly, then you will get a working printer. It will have the following attributes. And if it doesn't, if there's a design flaw, I'll accept liability for that. But my liability is limited to the cost of building the printer, which is $400. And I'm going to charge you $50 for that warranty. So that structure where you're charging people for the promise that the goods will work if they're correctly implemented, this then goes down to Bob. Bob then certifies that he's manufactured to your specification, and then you perhaps optionally bless Bob's implementation, and then you charge another $25 for that, or a third-party Q&A team comes in, verifies that this thing has been correctly built, and they sell the warranty. So what we're doing here is we're separating out. I gave them away the plans for free. If you want insurance that the plans are correct, you buy the insurance. And if you're doing something like sending these damn things to Mars and the cost of failure is gigantic, maybe you should be talking to Lloyd's of London about underwriting that. So it provides a way of tiering the risk. If it's low risk, I don't buy the insurance. If it's medium risk, I buy the warranties. If it's high risk, I buy special warranties from specialized providers. And what this provides us as a way of doing is risk compensating any kind of open source hardware project, because it allows multiple parties to come in and certify. So if you've got a set of plans for an open source car and you've got a sign off from, I don't know, one of the big insurers, AXA, that says, look, we've had 12 university teams review the plans and we're confident this thing is roadworthy. You can drive it in the following 6 countries and we'll sell a guarantee of that. Every time you buy one of these cars, you're going to buy that guarantee from AXA. So you, in the event that you get sued because somebody says your car isn't proper, AXA picks up the tab, not you. And this is basically providing, a lot of the reason that corporations exist in the hardware domain is to soak up the risk of what happens when things go wrong with the hardware that they're selling. So finding ways of soaking up the risk without creating a whole new set of opportunities for corporations to do their thing is sort of the goal state here. Because I'm pretty sure that the risk absorbing function is necessary. I think we need entities to be able to soak the risk of things like badly manufactured hardware or poor design. But what we don't want is to have those corporations be broad in their scope of operations. Insurers, although they are evil corporate bastards at heart, they're still evil corporate bastards that work for you because they sell insurance to you, and they have a very, very limited, tight, narrow scope of operations. And if you think of things like underwriters, laboratories, they've been ensuring the quality of domestic appliances for, 60 years or something. They really do excellent work on making sure that the stuff that you buy in the stores is safe. And so I think that if we figure out how to get the right interface between the open hardware community and the insurance community, we wind up in a position where open hardware becomes much more directly competitive with the stuff provided by corporations. I've been busy.
For sure. Okay, we are at 6:15 and we are approaching the end. So I think that it's very, very important that this dream team that we have the pleasure to have now today in this Fab 16 event could continue to interact, could continue to deploy some collaboration like Marcin says. And for that matter, we're going to enable a new sort of hypertext idea and project on our website, greenfablabnetwork.com, using, with your permission, your videos and some texts that enable to find out the best approach to resilience. Binai show us a very interesting feature that is the other AI. How is it named? Binai? Other AI?
Oh, Otter. Yeah. I tried to get rid of that thing at the beginning of the call and it's basically stalking me. So that will prepare a transcript of the call. And I can send that over later on. I just set it up today and it joins all of my calls automatically. And if I'm the host, I could kick it. But if I'm not the host, it just kind of sits there stalking us. So I apologize.
Yeah, there is tools like that, very advanced. And there is another tools also very advanced in order to get the most of a collaboration by taking advanced notes and advanced hypertext. I could show you, for example, this one, which is a way to take notes about a book, Bertrand Russell. And it is an advanced hypertext with graphs enabled. So it will be very interesting. Maybe we are talking with Professor Joshua Pearce. Maybe his book could be a good start for that. And however, we are trying to create the Green Fab Lab project as an advanced hypertext. So each approach, each technology, and each project could have a branch and more branch that could be enabled with another minds, another collective wisdom outside in the internet. So what we are trying to get is collective wisdom. The world is better because we have internet, and we have internet because at some point Linux enabled an open source by tackling the collective intelligence worldwide. And after that, it comes Arduino, and after that, it comes Open AI, and so on, so on. So I think that this could be a good start for the to continue this initiative. So I have pleasure to invite you to that, and I will send mails regarding this initiative. That is all for now. Maybe Anna has some words to say.
Sure, thank you. Do you have everyone's emails, first of all?
Yeah, please, could you put your mails on the chat so we could send it to you, the news of this initiative.
Excellent. And thank you, everyone. It's an honor to be on a panel with you all, and exciting to hear what you're up to. It sounds like there's a lot going on, from turning plastic waste into protein to enabling totally distributed quality control and insurance distribution, to just everything people have been working on around resilience and distributed sustainability, building up society, rather, whether it's today or for future potential catastrophes. I'm curious if we could go around. I think the elephant in the room is the fact that we're all on Zoom because there's a global pandemic going on and supply chains are still backed up for months. Have you all learned things? Is there, let's say, something hopeful that you're taking out of the current disruption that we can take on to our make sense and make resilience?
Thank you, Anna. Marcin, some final words to us?
Final words would be, I'd like to see, I mean, definitely there's a lot of common ground in what we can collaborate on. So people like Joshua, Vinay, or anybody else here, I mean, I don't know, how do we work on selecting problems that are larger and more of us working together, because the solution requires more of us to do it? That's the kind of logic that we have to think about. But I'd really love to invite you to think about it on your work right now. What could apply to with some of the people right now? I mean, I can definitely say Joshua and Vinay, right? I mean, right now, people are relevant to solving bigger issues. How does that apply to your work? So that's just a question for everybody.
Joshua, Professor Pierce, please.
Well, thanks. So Anna, that's a great question, and I'm at least, I started out quite optimistic. So when the pandemic initially hit, there was this enormous outpouring of people actually sharing open source ideas. There's pressures on companies to open source vaccines and ventilator designs, and the humanitarian engineers had like 9,000 people on a Slack channel at one point. Like, it was insane. And some good quality open source work got developed. Now if you look up open source ventilator, and I did a literature review on it right in the beginning, and there was nothing that was truly open source and worked. And now I think we've got a bunch of decent solutions depending upon what materials you have access to. But the sad thing is, there's still people working on the problems, but as soon as you are no longer threatened, the number of participants drop like a rock right back down to almost where we started. So I think that there's now an awareness within the greater community that all this stuff we've been talking about for years actually does work. And if you need it, it's there for you. But at the same time, this is one pandemic on one very small, problem, got a whole slew of problems that we need to be applying that same kind of energy to. And so I think we do need to find a way to make it more mainstream, make it more traditional, like that your default setting is open source. You start with sharing, and it comes from having functional business models where people can pay for their kids' shoes and stuff. We need to get there, and it's on that point, especially in the hardware community, we're very early on. I think technically we're more advanced already, but how to actually make the whole system work is still challenging. And so in the end, especially in the US, it's depressing, right? We had solutions, and now we're losing them. So we still have a lot of work to do. No retirement for anybody on this call just yet.
Yeah, I'm working with some political economists who have a background in law, and it's heartening to see from the legal industrial scholars who have no background in open source communities starting to ask things like, in the US, we have all this government funding that goes to proprietary solutions, which get captured by industry. And so why is it that we're using taxpayer money to really subsidize industrial innovation? And so there's a small but growing community of economists and legal scholars who are trying to push this.
Oh, that's a great question to ask.
Musakata really cracked that story.
Yes.
She, I met her once. She was on a panel at an event I was at, and she's about 6.5 feet tall and has the general demeanor of like Xena warrior princess or Red Sonja. She seems like, she should be wielding some kind of large axe or mallet or something. It is hugely intimidating. It's extremely impressive. I like to think that this is part of why she's been able to have so much impact. It's just people are terrified to debate her in case she gets seriously New Jersey on them.
The corporate lobby is strong. We'll need some Amazons.
Yeah, absolutely. I can't remember. It was she was debating some right winger, and they were kind of rude to her, and she just kind of menaced over them, but they looked physically frightened. It was hysterical. It's like, that's how you get this thing done. So my take on this is that we need to move into a post-optimism perspective, right? At this point, optimism is a liability. Because if we're working based on optimism, I guarantee you the next 10 years are going to kill you. Right? We're just going to get the metric hell kicked out of us. Tens or hundreds of millions of people are going to wind up being completely screwed by climate change. Maybe they'll die, maybe they won't. It's going to be horrific either way. And politically, we're not done with this far right swing. You've got 2024 coming right around the corner. So I think we need to move into, and I really mean this, right, a post-optimism mode of engagement. Right? We're not going to win. We're not going to save the world. The world is going to smash right off the barrier, right? And if we're unlucky, it's going to go through the barrier down the cliff. But if we're lucky, it's going to careen off the barrier and then come to rest against a tree on the other side of the road. Right? But we're no longer in the domain where if we work really effectively, we can avoid the trouble. We're more in the domain where if we work together, then maybe the car will be a write-off, but the passengers will walk out of it. And that kind of post-optimism approach, right? We're now negotiating with various degrees of bad, and we're going for least worst. And a least worst motivation comes from a very different place from imagining a beautiful world and trying to get there. And the more psychologically we adapted we are towards least worst, the less of us will get broken by having their optimism completely betrayed by history. Has anybody heard of this movie called The Coquettes? Heard about this? So it documents the passage. I'm going to send a link there. It documents the passage of San Francisco acid drag troupe in the 1960s. But one of the things that comes up in the course of the movie is a description of the economic system of San Francisco during the height of the commune movement. And it's staggering and heartbreaking. You know, it explains how the hippie economy really worked. And, you know, it's just like they built a little micro utopia basically on government welfare checks and mass collaboration. And it was super efficient for the 5 years that it lasted. So we've come through several rounds of these cultural flowerings, the 60s, the 90s. On each occasion, we learn a little bit more, but the hope that we were going to achieve systemic transformation before the world ran right into the wall, I think we need to let that hope go. And we need to start thinking ourselves much more as like military or medical personnel, where, you know, the car crash, it's like, oh, it's already happened. And now we have to start thinking about what it is for us to go in there and start mopping up. You know, and it's a different mindset. It's far more endurance based. It's far more about just put one foot in front of the other, because what the hell else are you going to do with your life? And I think that we need to cultivate this thing, which is much more military or much more medical, rather than the kind of, you know, 1950s style techno optimism, which is always run through the open source movement. It's always run through the commons movement. You know, this stuff is now a matter of least worst, and it's a matter of survival. It's not about getting to the preferable future. It's about minimizing the damage we take from the, you know, awful, awful present, which is right on track for getting a lot more awful really quickly.
Vinny, I wish you had led with that. We could have had a good debate this whole time.
And it's going to get worse before it gets better, right? And this is not to say that it's not going to get better, but that trough that we are going into, wow, it's a bear.
Under the assumption of non-collaboration throughout, which is the current case. But
hey, there is no magic collaboration theory. It's not a thing.
All right.
Right? In small groups, sure, that's a well-proven, that's happened a lot, right? But if we keep hoping for the magic collaboration theory and what we get is people bulldozing refugee boats back into the sea, we're going to get heartbroken. And I've seen the 60s generation get heartbroken, and I've seen the 90s generation get heartbroken. Heartbroken makes people ineffective, and it often shortens their lifespans remarkably. Right? What I'm suggesting is that we let go of the dream that it's going to be okay, and we start getting really pragmatic. Like, we are medical personnel. We are here to do the best that we can with the triage situation you've presented us with. And when our shifts are over, we will go home and we will sleep and we will be back tomorrow. You know, because doctors don't operate from home. 100% of their patients eventually die. Right? It's a completely different mindset from the utopian visions which have motivated so many of us in this field. Right? And letting go of utopia and moving towards damage limitation, you know, it's like ending the war of drugs and moving towards the Portugal model. There is a point where we have to face reality, and reality is this is going to suck for a while, and then we will eventually sort it out, maybe. So that's my take. Post-optimism.
Is that a word, or did you frame that?
Say again?
Is that a technical term, or did you just come up with that?
Post-optimism, it literally just came out of my mouth. I have no idea.
Thank you.
Marcin, you gotta save us, bring us back to at least a little bit of optimism.
That's what I'm saying. It's like, man, that shift is overnight. Oh man, maybe we'll get there within a few years. We're working on it. A few years. It would be the earliest if we had a major acceleration in our scalability. It's possible. It's not impossible.
I like. There's truly horrific things going on in the world, but at the same time, many of the trajectories that we're all a part of are fantastically great. So solar price declines as an example. The switch over to EV cars, like we got so many things heading in the right direction. And even open hardware. Right. The citation rate of open hardware is growing exponentially, and it's 15 years behind open source software. And so if you think about open source software now, it's dominant. Like it's the way every company that has anything to do with the internet is running, at least on the back end at this point, and many on the front end. And so I'm far more optimistic. I think we can still get out of this. We're going to have a lot of death and unnecessary suffering, but we have always had that. And so there's no, you don't have to feel particularly bad about that. We can just try to do the best that we can and still look at the bright side of things. Medical model.
But the bright side makes us very vulnerable to history, right? I mean, I'm a product of the 1990s wave of the psychedelic revolution. And believe me, we invented Plur, right? We were all bright side all the time. And we've aged horribly because the enormous disappointment in the human race that comes with being an optimist basically just breaks people, right? You know, culturally, and I can't overstress this, our inability to look to the downside is what left us vulnerable to having, sure, open source software now runs the world's industries, but 100% of the value captured by those industries is not going back into the commons, and the open source programmers are so broke unless they're working for Google. You know, the guys that worked for 2 decades on FreeBSD did not get paid out by Apple. And that is not a sign of victory. It's just a sign that capitalism has figured out how to capture the commons, squeeze the wealth out of it, and leave the people who actually did the work on these things broke. The only reason Richard Stallman has a roof over his head is because somebody in San Francisco wrote him a check, and you know, the regular income stream from some guilty .com billionaire is why Stallman still has a place to live. Right? If we don't get much better at looking to the downsides on this stuff, we are literally going to wind up as speed bumps. Right? Because how much money did Apple make from FreeBSD? Right? Conservatively, it's probably $50 billion or $100 billion.
Yeah.
I don't see the FreeBSD guys paying off their mortgage because Apple used FreeBSD. That's exploitation. That's not victory. Right?
Yearly MakerBot scandals.
Yeah, exactly. Right. So we might be successful in being massively exploited by capitalism, but that is not the same thing as winning. And the cultural trajectory that we're on, the far right is not gone. Right? The climate stuff, you know, 50 degrees in Europe, 50 degrees in Canada, 50 degrees in Portland, 50 degrees in India. Greece burns to the ground. You know, like, it's going to be a really grim 10 years. And I think pre-adapting to that is one of the healthiest things we could do. We have to beat the rainbow unicorn stupidity out of the movement if the movement is going to be meaningful in a world that has hundreds of millions of people being displaced by climate change or tens of millions of people dying on sight. You know,
but on the other side, what about the comment of, okay, hardware is a different phenomenon than software. It can scale faster at an inflection point. What about that possibility? Is that,
sure,
how does that weigh in here?
I mean, the possibility was that the age of Aquarius was going to come and LSD was going to awaken humanity, right? That was the 60s version of the story. The 90s version of the story was the internet was going to awaken humanity and it was going to enable mass collaboration. Well, it did, but not for the good people, right? I don't
know. I would argue internet's brought a lot of good. We have more educated people now.
Oh, it's both.
Wikipedia, with all of its faults, still is vastly superior to anything that commercially has ever been made available.
The victories are magnificent, but the downside is anti-mask and anti-vax propaganda has probably killed, I don't know, 500,000 Americans this year alone.
But at the same time, I would argue that open source phenomena have saved more lives than that. So we still have work to do, but a lot of the trajectories are actually, you know, without being, you know, pink visioned or anything, actually pretty good. So if you compare when I started in solar work in grad school, the idea that we could get a PV panel under $3 a watt was that was like the dream. And once we did that, we were all going to like retire. And now you can buy it for under 30 cents. Like,
absolutely.
And if you look for a deal, you can break that in half again. So it's many of the areas are all headed in the right direction. We still got terrible stuff to get through.
They're headed in the right direction, but they're 30 years too late.
Thank you, Marcin.
Hey, take care, Marcin. And you know, the reason this matters is if the psychological, philosophical, and emotional preparation is not there, right? As the world gets dramatically worse, which it's inevitably going to before it gets better, if it gets dramatically worse, what happens is that the leadership of the movement gets ripped to pieces by trying to maintain this false optimism bubble. I saw it happen in the 60s. I've seen it happen to my peers in the 90s. And, you know, this kind of open hardware thing, like the open source software thing before it, because we're so bad at looking to the downsides, because we're so bad at recognizing when we're being exploited rather than being integrated, because we confuse being used with being victorious, we're in a position where the movement basically lacks the necessary skills to survive in a much, much, much meaner, tougher, darker world, right? The utopians get screwed on every cycle. The world comes up, everybody gets real utopian, the world goes down, the utopians get used for mulch by bastards. So if we're going to avoid the same fate as open source software, which became a gigantic enabler of capitalism without managing to capture any of the value, because the legal agreements didn't protect them, we're going to wind up with open hardware going down exactly the same trajectory. Sure, there'll be 100 million open source cars on the road, but they'll all be manufactured by a single company and they'll all have a bunch of brains inside of them that report to HQ and the car doesn't drive otherwise. And it will be the law that it has to be done that way. That's the kind of scenario that we can prevent with the correct use of IP licensing and the correct philosophical foundations. But if we don't get really smart about this stuff, we're going to wind up like the FreeBSD guys.
If you look at all the open source software guys, I think the FreeBSD guys are the minority. So you have the majority of coders now working on open source projects and being paid. And yes, it's either they're startup companies or they're working for Google or Facebook or whoever. Like these are people earning a living, supporting their families, and contributing to the commons in a very real, productive, useful way.
But it's
they've enabled all of us. So like, even if you're talking to me on a Windows laptop or an Apple laptop right now, you have the option to download a completely free version of Linux for free that will work for sure. And that wasn't available before the open source software guys got started. And so,
but how different is that world to the world in which GPL v3 simply transferred the wealth of Silicon Valley directly into the pockets of the people that were writing the open source software that powered Silicon Valley, right? Stallman's point that $1 trillion leaked out of the commons because GPL v3 had a bug, right? We have that bug in the open hardware movement. And if we don't close up that bug, another $1 trillion will slip out of the control of the commons into hard capitalism.
But I don't think that hurts us. So like when I design something,
how much better off?
Hold on. So right now I'm paid.
This is important.
Wait. Right now I'm paid to make open source hardware.
Sure.
And I could be paid to patent something and try to make money off of license agreements in the future. But I'm paid now. You can make a copy of anything I've ever designed, and if that benefits you in some way, great. If you make a profit off of it, great. It doesn't hurt me for you to be making a profit off of it. You didn't steal anything from me. I still get my stuff. I still got paid to make it. And if I can help 1,000 other people fabricate the same device, all the better. Like I've lost nothing. I've only created more value. And if you happen to capture some of that value, good on you, because you're having to take the time to count out M3 nuts and bolts. Like I don't want to do that. I've made the devices for my own use, or I've made the devices on a contract, and everybody wins, only much more so than if I followed the old model where I patent every idea. And then you can't do that. You can't fabricate my devices unless you pay me a license agreement. Now I'm respecting your freedom to do whatever you'd like with any of my ideas.
Right.
I'm paid. You have the potential to profit from it, and so does everybody else in the universe.
Sure. But Solomon's point about the leak in GPL v3 is that the people built enormous piles of value on top of the bedrock work done by the free software community, and none of that value went back into supporting that community. You're exceptionally lucky to get paid for working on hardware. Of all the people out there that are working on open hardware, a tiny fraction are being paid. Of all the people that are being paid to write open source software, they're being paid to write that software by enterprises that have no fundamental interest in the success of open source. The vast majority of those people are cogs inside of Google or Facebook, building an extractive economy using open source as an enabling technology of a global information holocaust.
But when the Facebook engineers design an open source server, that benefits everybody, because now they're benefiting themselves the most. But we all benefit.
What they're doing with that platform is they're then monopolizing the world's social graph, right? Because what they're doing is they're running all their servers at an extremely low cost, and then they're using those servers to take proprietary control of information on absolutely historically unprecedented scale, right? The open paradigm, it's opened a tiny pool of information in the form of, a few gigabytes of Wikipedia and Linux, but hundreds of thousands of petabytes of information are then being stored in that software, all of which is proprietary, closed, and a lot of which is toxic to collect, right? We're in a position where we have enabled evil on a titanic scale because the licenses gave us no control over the fruits of our labor, and capitalism then just used us as a resource to implement a set of agendas that are fundamentally hostile to the human race.
So,
and that's going to happen with hardware too, if we don't figure out how to plug the holes that Stallman identified in the software licenses.
So you're thinking something like an open source ethical license? Is that?
I'm thinking that we need to understand that what we have done is enabled evil on a titanic scale where we thought we were helping. Right? Once we understand, like, wait a minute, so we let the FANG companies arise because they weren't paying anything like the fair price for the software they were using, because the open licenses just removed all friction from the growth of the FANG ecosystem. And the people that created that software captured none of the value, right? If we had seen $1 trillion value transfer to the commons, even if it was 200 billion, imagine what would have happened if 200 billion had gone into, Linux, Apache, FreeBSD, Firefox, right? You have a completely different landscape in an environment where the open source community got reasonably paid for their work when it was adopted by large corporations. And I think that we have to consider the opportunity cost of not having the clauses in the licenses that prevented that is everything that could have been done with $200 billion worth of free software millionaires and billionaires.
So do we have in software or hardware, but probably software, do we have a license agreement that plugs all the holes now to work?
There are things like the FARO, which basically say if you are selling software as a service, you have to release the software that you are providing the service with, right? Not much software is licensed that way. I seem to remember there was a set of discussions about GPL v3, GPL v4, different clauses, maybe the ways of closing up the hole. I don't have a solution for this for hardware. I don't have a recommendation for it. In hardware, you're beginning to look at things like patent pooling. It's very, very, very hard because patents are stupendously expensive. They're very hard to create. They're hard to defend. But I think if we start thinking about this stuff now, 5 years from now, we might have a comprehensive solution. Because what I don't want to see is that we create a friction-free capitalism, which is now capable of doing hardware friction-free in the same way that it did software friction-free, and we wind up with the creation of a new generation of Apple, Facebook, Google, but this new generation are hardware companies that run on open hardware, and they do exactly the same side of colossal global scaling and capturing of power that was enabled in software specifically because of the free software and open source licenses.
Excuse me, Vinay.
Okay.
Did you hear about interplanetary file system?
Mm-hmm.
Did you hear about interplanetary file system?
I use it. I use it commercially. I use it commercially every day. My software
amazing
runs on IPFS. Yeah, it runs on Ethereum.
This protocol allows you to design and preserve the growth of humanity's knowledge. Most important, it makes the web upgradable, right? And if someone wants to censor you, they can't. So yeah, that is a way to fight censorship and totalitarianism.
Sure.
Okay. So could you elaborate more on this, because that is so important, and to have, on the base that protocol and over there a blockchain. That is the architecture of your endeavor.
Yeah, we use the Ethereum blockchain and IPFS. That's where all the documents are stored. But the problem is that all the information about vaccine denial and mask denial and QAnon and all the rest of that stuff, right? If those people were able to use IPFS easily because the software existed that made the user interface easy, all that you would have is the entire world of bad conspiracy theory and fascist organization would be happening in the IPFS world. I very nearly sacrificed my professional reputation in the Ethereum world to kick the Nazis off Ethereum about maybe 3 or 4 years ago. I mean, I really went out on a limb. I got involved in some absolutely brutal public war, basically saying, like, look, if we let the far right colonize our platform, what will happen is they will use it for financing terrorism, and then people will die. And there was no support from the foundation. There was no support from the community, but I managed to make enough of a stink that the Nazis kind of decided they were going to do their own version rather than use ours. And the Gab team, right, stood up their platform. Less than a year after I made that stand, the guy that went in and shot a synagogue basically declared what he was going to do on Gab. A whole bunch of people cheered him on, and then he went off and killed like 15 people in a synagogue. Like 11, maybe. So, you know, I'm already in a position where keeping the Nazis off Ethereum was a thing that I committed everything I had to, and that was critically important, which is why we don't have, you know, the far right using technologies like Ethereum and IPFS. Right? And that was a dangerous, dangerous thing to do. I watched my back in a very serious way after doing that. So, you know, we're not operating in the 1990s anymore. We're operating in a position where every single one of these tools can be put to deadly use by our enemies and are being. You know, it's a really serious problem that we have conspiracy theorists telling people not to get vaccinated in an age of pandemics, and even worse, telling them not to wear masks. And then these havens of infection. I mean, you know, if Texas turns out to be the thing that breeds the version of COVID that has a much higher fatality rate, we're really going to pay for the disinformation campaigns that cause Texans not to get vaccines. This stuff is incredibly serious, and our cultural values were rooted in a time when the world was much kinder than it is now. We have to adapt.
This is also fundamentally a sort of democratization challenge too, no? Because you've now given anyone who wants access to the internet where they can find their own communities and band together, you know, that exacerbated by profit-driven organizations who will be looking out for their own profits. And, you know, capitalism eats land, labor, and capital, that accumulation and monopolization of technology. So I think are we short? Yeah, thank you, Joshua. I think we're short on time, but to be continued. Fascinating discussion, everyone. And yeah, I'll leave it to Marco to close up the session.
Yes, thank you all. It was an amazing talk. I'm very, very honored to have you as guests. So I will keep in touch with all that mails, and we're going to publish all the videos that you gentle offers us to for diffusion, for further watching. So, gracias amigos, muchas gracias por estar esta noche con nosotros, y les envío un fuerte saludo desde mi país. Gracias otra vez. Hasta luego.
Thanks a lot. Great discussion.